Good morning, all of you. Today we'll discuss about the motion magnetic field due to moving charge particles, then moving charged sheet, then due to rotating charged structures. That one. So altogether, a non-conducting charged object. What about the field produced due to its motion? Or this particular topic we can put like a magnetic field due to moving charged systems. Also very important, we don't have any good question till now in advance. This is the only topic left over. So better what happen, what are available, some 10 questions are there. Work out all, you'll be on safer side, no? Because in books only one or two problems are there and they're coming out. No much discussion are there. Okay, these are already, yesterday we discussed the formula, no? So now we are going to take now two charges are there. The magnetic force explained by charge Q1 due to other charge Q2. The magnetic force explained by charge Q1 due to other charge Q2. Both are moving. So let's calculate the field at the position of one due to for field produced by this one. So B2 will be equal to mu naught Q2 V2 bar cross R bar by 4 pi R cube. There's a formula. So what is R? R is the line joining AB. So there's the line joining the charge particles AB. So there's a position A, there's a position B, and charge particle, positive charge particle. Let's take here this one, and this particular charge particle, it is moving here. At the location of that, we should calculate the field. Let it be positive charge particles. A is given, no, two positive charges. So what is the value of B2? So we don't in vector form. So what is that position vector R bar? You can define minus AI cap plus AJ cap. So in the vector form, when you write it, mu naught Q2, V2 will be V2 J cap cross R bar will be minus AI cap plus AJ cap. Four pi. This will be like a root of A square plus anybody value R cube. How much it will be? R will be root of A square plus A square. A root 2. So A cube 2 to the power of 3 by 2. Or 2 root 2. This much is there. So we'll take the cross product of this. So this should be the B2 is equal to mu naught Q2 8 root 2 pi A cube J cross I minus K. So this will be V2 A cap. J cross J, it will be 0. Okay, this is the value of the magnetic field. So mu naught Q 1A get cancels. Q2 V2 by 8 root 2 pi A square. Now there's a magnetic field. So how much it is? B2. Whatever the direction should be out of the plane. According to or V bar cross R, this R bar, no, curl fingers from V2 bar towards R bar. So at that particular location, it will be out of the plane. The field will be out of the plane. You have everything, no? Here K cap. No, it will interact with this. So F is equal to, apply the formula now. So what is the formula? F1 is equal to Q V1 bar cross B2 bar. This is what the force is asking. So this is Q1. So Q1, V1 is V1 I cap cross mu naught Q2 V2 K cap. So mu naught Q1 Q2 V1 V2 8 root 2 pi a square. I cross K, K cross I will be J I cross K minus J. This is what F1, no? What is this F1? Any name shall we give? Force acting on the charge particle 1 due to field produced by the moving charge particle 2. Now, this is the thing. Force acting on 1 on Q1 due to field produced by Q2. Shall I ask either way? What is the force acting on the F2 on the second charge particle due to moving charge Q1? Will it be equal and opposite? Will be equal and opposite. So we have to be really very careful about the conditions here. No, there's a question sequence. Okay, similarly, let's calculate here. So what is the calculation now? He didn't ask anything. Just he asked us to end up here. Okay, we got the answer. Let's work out in other way. Will charge particle also will it experience this much of force only? So first we'll calculate the location. At the location of here, B1 will locate it. This is yeah. What do you mean by B1? The field produced by the charge particle 1 at the location of second charge particle. Again, apply the formula, get the V1, B1. Then you can write Q2, V2 bar cross B1. Let me call that as F2. Let me work out for B2. And some good conceptual questions can be asked here. This I just picked up this one. Let me come for this. Okay, proceed with the same calculation like earlier what we did. I had the location of this one. So here it should be equal to B1 is equal to mu naught Q1 B1 bar cross. This was earlier we defined R cap, no? So you define that as bar. Later on we'll change symbol. 4 pi SQ. What is S bar? S bar should be minus of R bar. So V1 I cap. This should be minus A I cap plus A I cap minus A J cap. 4 pi. In fact, S is equal to R, no? S is equal to R. So same 2 root 2 A cube. Two root 2 A cube. This. I think I should not solve, no? It is naturally understood. What is the natural understood? It should be equal and opposite from Newton's third law. So I cross I will be 0. I cross J will be K. So V1, so this I'll end up with minus K. So 8 root 2 pi E cube, or finally this is equal to mu naught q1 k cap by 8 root 2 pi E cube. This is B1. This will be into the plane, B2 was out of the plane. Let's calculate now F2, force acting on second charge particle. F2 should be equal to Q2 B2 bar cross B1 bar. So minus K cap B bar. So it should be like a I cross K. So will plus J will I get it, no?
Sir, velocity is in J direction, no, sir.
Velocity is in x-axis, no?
It is in J direction, sir, in this second case.
Oh, this is J direction, no? J cap. Better I'll write it. Yeah, J cap cross minus of mu naught q1 v1 8 root 2 pi a square. This is q2. Final value f2 should be, and j cross k will be I minus I am getting j cross k I, so this will be minus of mu naught q1 q2 v1 v2 by 8 root 2 pi a square minus I cap. They're not equal, no? How come? Something wrong is there? So how F2 will act along negative x-axis? How F1 is acting? The J cap, you see this? So let me show that forces here in the diagram. So how this should be? The force acting on Q1 due to this one. So minus J cap. So that force should be downward here, no? That force should be downward here. And this is the positive charge particle. Now, similarly, this one, this is F2, no? F2 should be here, F2 minus I cap. So force acting on, this is one we took for on Q1 due to, I'll make correction. This is correct here. This is F1 here, right? And then what about F2, force acting on minus I cap? Look at this, something we expected that to be equal and opposite, no? So therefore net force on the system, but we ended up something somewhere in a, so shall we leave it here only? Sorry, it happens in magnetism chapter like this only, let's not bother. What about Newton's third law? Is a basic law, no? Should be obeyed. So where it has gone, no? Nice opportunity for you to think. Basic fundamental. In terms of basic fundamental, there's a nice opportunity what teacher is giving for students to think. So there is some, we are missing that field, no? Actually a charge particle moving in a field. The charge particle expends force. What about the field? There'll be field, no? Actually what is F1? Things are like that. No? What is first, we'll do one thing. That B1 is there, no? The second charge particle will produce B2. charge particle 2 which is moving, what will produce B2. Where F1 will be acting, F1 will be acting on B2. Similarly, what happened? The first charge particle will produce field B1. And this field will exert a force on the charge particle Q2. In turn, what happened? The charge particle experiences a force on the B1, the field B1. I think I should not show field here one point and I'll show force, but for your understanding purpose, I'll just show that force here. Don't scold me, sir, how can you show like this? Just to make students to imagine. Is it okay? I think little bit easy to imagine now. Okay, let's come for this one. Let's come for this. The moving charge particle 1, this moving charge particle 1, it will produce a field B1. Got it? It will produce a field B1. Then this field will exert a force, no? That is F2. In turn, what happens? The charge particle will exert force on this field B1 produced by that one. That is F2 here. So I should not show at one point. Again, don't scold me, sir, what you are doing. Just only to make you to imagine. Because where field will be? Field will be everywhere. From where? From the location of the point charge Q1 to till where? Till the infinity, no? It will be. So where this force will be acting? Throughout the field. I'll discuss tomorrow. The frame of reference, I'll discuss tomorrow, that one. Frame of reference we'll discuss tomorrow. Is that okay, no? So there's a simplest way. This F2 I should not show like this. I'm making things clear. Where this F2 will act? F2 will act throughout where all the field due to point charge Q1 is there, at all points this force will be acting. Just imagine. It's something very difficult to analyze, no? As in quantum mechanics, we have a suitable way to express. But as far as classical mechanics, we have to just say that the force. So don't show F2 at one point. For your understanding purpose only, I'm showing that one. So there are Newton's law is a valid. It's a fundamental law. It must be valid here. So that missing force is what we should search here. So therefore, if a field exerts a force on a charge particle, in turn, charge particle will exert a force on the field. In turn, the charge particle will exert a force on the field. So the missing force is what we have to show like this. So still, and don't show F1 equal to F2. Sir, what about magnitude? Okay, you are talking about magnitude, okay, but don't write F1 bar equal to F2 bar. They're not equal. Getting the idea? This is so they may test you with all these basic fundamentals. So now the field produced by the point charge. So here what will happen? The B1, where it is present, it is present throughout the space from here to till infinity. So at all points, the field will experience a force. Just imagine, sir, how field will experience a force. So this is what happens in electrodynamics when we go for the higher part of the electricity magnetism, no, the electrodynamics. They're all these are taken care. So I'll just stop it here only. So any fundamental question can be asked for you.